What's up everybody, this is John with John Fair Innovations bringing you another math lesson. So today I'm going to show you the fundamentals of triangles. So after today you'll know everything you need to know about triangles. Now before I get to the video, if you enjoy it, do make sure you hit that thumbs up button, leave a comment on maybe another math topic you'd like me to tackle, and if you really enjoy the video, do make sure you hit that subscribe button so you can stay up to date with all the videos as they come out. And apologies for my voice, I've got a little bit of hay fever at the moment, so if I sound a bit weird, that's why. Now obviously, triangles are a fundamental part of mathematics, specifically geometry. And we use a lot of these for calculations, helping us understand different problems and also things in the real world. So knowing what a triangle is and how they work is really important. So firstly, to start off with, a triangle is what we call a two-dimensional shape or 2D shape. And that simply means is that it's a shape on a flat surface. So you draw it on a piece of paper, for example. It's something that, is flat. Now, the word triangle refers to triangle, which is, I know that sounds a bit silly, but basically if we break it down, we have tri, which is of course the prefix meaning 3, and angle of course refers to the space between two lines, usually represented as degrees. So when we calculate the angle of something, it's usually done with, like, say, a protractor, for example, where we work out how many degrees it is. So a triangle is a two-dimensional shape that has 3 of these. And it's also important to note that triangles always have 3 angles, 3 sides, so like the lines around the perimeter, and of course the angles, and it's very important, always add up to 180 degrees. Now this is really important because this helps us make calculations. So if we know for a fact that we have 2 angles, we can work out the third one without even having to use a protractor, because we know that the 3 angles together have to equal 180 degrees. So that is a fundamental part of triangles. Now, triangles can be broken down into different types. And we have 3 main types, which are equilateral, isosceles, and scaling. Now, equilateral, as you could guess by the sound of it, refers to equal. And when we have our 3 sides, like all triangles do, these 3 sides are all equal to one another. So if I have an equilateral triangle where one of the sides is 1 centimeter, that means every other side, the other 2 sides, have to also equal 1 centimeter. And usually we put a little line through the side just to denote that these are all equal, to let you know that they're an equilateral triangle. Now, because as well that all the sides are equal, the angles are also going to be equal, because remember, angles are the area between 2 lines, and if they're all the same, that's going to produce the exact same angle. And we can actually do a little bit of math to show that the equilateral triangle has to have each angle equaling 60 degrees, because we know for a fact that triangles have to have 180 degrees in total, and we know that they have 3 sides that are all the same. So we simply have 180 divided by 3, and that would give you 60 degrees. So that's another property of an equilateral triangle, is that they all have angles that equal 60 degrees. It doesn't matter what the sides are, as long as the sides are all equal to one another. So it could be 1 centimeter, it could be 100 meters, it could be a kilometer, it could be 0.25 millimeters. Doesn't matter. As long as they're all the same, we know for a fact that the angles are all going to equal 60 degrees. And so that's equilateral triangles. So now we can move on to isosceles triangles. And isosceles triangles are where we have 2 sides and 2 angles that are the same. So that's really important. So 2 sides will be equal to one another, and again we usually write a line between the 2 that are equal to denote the fact that they're both the same. And again, because these lines are going to have a same relationship with the third non-equal side, it's going to create 2 equal angles. And then obviously, if you know this, if you know that they're in equilateral triangle, you can also make calculations to be able to work out the angles without having to use a calculator. because you know that two of them have to be the same, and you also know that altogether they have to equal 180 degrees. So if you, for example, if you knew that the angles that were equal to one another were both 70 degrees, for example, you could work out the third one, because you know that, well, if I have two of them that are 70 degrees, because they both have to be the same, that gives me 140 degrees. So what's remaining of 180 is in fact 40 degrees. So that's what has to be the third angle. So again, you can use this property that you have two equal angles, two equal sides, to be able to make calculations on it. Now the last one we have is, of course, scaling. And scaling triangles have different sides and different angles. No two angles and no two sides are exactly the same. So you could have a triangle that has maybe sides of 3 centimeters, 4 centimeters, and 5 centimeters. This would also create angles that are different from one another, because the lengths are different, which is going to create a different relationship between them, and it's going to create different angles. So scaling, everything is different. There are no two same sides, no two same angles. But again, still adds up to 180. So if you have two of the angles, for example, you could be able to easily work out what the third one should be. Now, lastly, what we've got is a subsection of triangles, and it's a way that we can describe these, our equilateral, our isosceles, and our scalene triangles. And we can sort of describe them in terms of their angles as well. So the three main angles that we have in mathematics, in geometry, are acute angles, obtuse angles, and right-angled triangles. Sorry, right angles, I should say. Getting ahead of myself. So acute angles just means an angle that is less than 90 degrees. An obtuse angle is an angle that is more than 90 degrees, and a right angle is an angle that is exactly 90 degrees. So another way we can describe our triangles when we look at them, because unless it's an equilateral triangle, they're going to have different angles, and they're going to have different sort of properties to them. So if your triangle has all angles that are less than 90 degrees, so your equilateral triangle, for example, we can say that this is an acute angled triangle, because every single angle in the triangle is less than 90 degrees, so it has three perfect acute angles. Now, we can also describe them in terms of obtuse. So if one of our angles is more than 90 degrees, we could say that this is an obtuse angled triangle. So you might have an angle that is 110 degrees. So if you have a triangle that has one of those angles like that, the other two add up together, and all three will give you 180 degrees. The fact that you have this one angle that is more than 90 degrees, we can say that it is an obtuse angled triangle. And lastly, as I said before, I got a bit ahead of myself, if it has a angle which is 90 degrees, so a right angle, we can describe this as a right angled triangle, because it has a right angle in the triangle. And when we're showing a right angle, not just in triangles, in geometry in general, we usually put a little square where the triangle is, where the angle is, and that represents the fact that it is 90 degrees. So if you see a little square like that in the corner of an angle, especially if you're dealing with triangles, you know that it's a right angle. So if you see it in a triangle, you know it is in fact a right angled triangle. So now I've got a few examples, and we're going to see just a little bit of some real examples of triangles, and see if you can work out whether they are equilateral, isosceles, or scalene triangles, and whether they would be described as acute, obtuse, or right-angled triangles. So we've got our first one here, and we've got a triangle, and it's got two sides that are equal to 6 centimeters, and its base, its third side, is equal to 10 centimeters. And we can also see that it's got two angles equal to 34 degrees, and its last angle is equal to 112 degrees. So firstly, is it equilateral, is it isosceles, or is it scalene? Yes, of course, it is in fact isosceles, because it has two sides and two angles that are the same. It has two sides that are equal to 6 centimeters, which creates two angles that are equal at 34 degrees. Now, can we describe this as acute? Can we describe this as obtuse? Or can we describe this as a right-angled triangle? Of course, we would describe this as an obtuse angled triangle because the angle on the top there is represented as 112 degrees, which is, of course, a lot more than 90 degrees. So it has an obtuse angle within the triangle. So it is, in fact, an obtuse angled triangle. Cool. All right, let's on to the next one. So we've got here, it's a triangle. It's got the sides are all the same, so they're all 3 centimeters, all 3 sides, and we've got angles, and they're all equal to 60 degrees. So is it equilateral, is it isosceles, or is it scaling? It is, of course, equilateral, because they are all the same. The sides are all equal, and the angles are all equal. So when in doubt, if you're trying to think, what's the one that's all the same, think of the one that sounds like the word equal, equilateral. That's the one that represents all sides and all angles are equal to one another. All right, now maybe a little bit more trickier. Let's see if you can work out whether it would be described as acute angled, obtuse angled, or right angled. So of course it would be described as acute angled because every single angle is less than 90 degrees. So all 3 sides have angles that are all acute because 60 degrees is of course less than 90 degrees, and we have 3 of those. So the fact that they're all represented as acute, we would describe this as acute angled triangle. Cool. All right, last one. So we're up to our very last example. So let's see if you can get this one right. How have you been going so far? I'm sure you've been smash it, you've been doing well. So last example, here we go. Let's make it a good one. So we've got a triangle, and it's got a side that has 3 centimeters, a side that has 4 centimeters, and a side that has 5 centimeters. It has an angle that is 37 degrees, an angle that is 53 degrees, and an angle represented as a square. So firstly, is it going to be equilateral, is it going to be isosceles, or is it going to be scaling? It is, of course, going to be scaling because we have 3 different angles and we have 3 different sides. So the fact that nothing is the same means, of course, that it has to be scaling, because scaling is the one that doesn't have anything equal to one another. Now, lastly, is it going to be described as acute angled? Is it going to be described as obtuse angled? Or is it going to be described as right angled? Well, the big clue is the fact that it has an angle with a square, which what we said before is always represents 90 degrees or a right angle. So this is, of course, would be described as a right angled triangle because it has, in fact, a 90-degree angle or a right angle. Well, there you have it. Hopefully you enjoyed that. Do review this. Do have a look at some other triangles, some other examples. Play around with a few triangles as well. Like, whether you want to, go on computer, or if you want to just draw some on a piece of paper and have a look at the relationships between one another. And you'll find it's really fascinating. You'll find that, you'll get the same angles if you're looking for, like, in an equilateral or an isosceles. Or if you create a scalene, that they'll all be different. But always stay safe, be kind to one another, and I'll see you next time.